We're going to begin this problem about maximizing area on here, and then I'm going to switch over to my calculator to help me answer some of the more difficult parts of this question. What's going on is, in this case, I've got 800 yards of fencing to use to make a rectangular fence, and I want to figure out what should my dimensions be to maximize my area. This problem's kind of dumb because it turns out that no matter what, a square is always going to be your maximum area. So knowing that, I can just take my 800 yards, divide it by 4, and make a square. But let's pretend we didn't know that and kind of see the math behind this. So here's how this is going to work officially, the long way, I suppose. Well, these two sides of the rectangle I'm going to call x. I'm going to pretend I don't know that it's supposed to be a square. I then have to think what's left over for the other two sides of this rectangle. Well, I've got 800 yards total that I can use. And I've already used two x's. So 800 minus 2x would represent what's left over for the other two sides. Well, those other two sides have to be evenly split. This 800 minus 2x has to be evenly split between those two sides. So if I divide both of those terms by 2, I see that the remaining sides need to be 400 minus x, and then 400 minus x. And we've done a problem like this part before. To then express my area as a function of x, this part of the problem, I'm just going to set up an area equation. Well, area of a rectangle is just base times height. So the area as a function of x would simply be 400 minus 2x, or I'm sorry, 400 minus x times x. And once I go ahead and distribute, I can see that my simplified area expression, or area equation, is just 400x minus x squared. Okay. At this point, let's switch over to our graphing calculator to graph this parabola and find its maximum value, even though I know what the answer is going to be because I know the maximum area is going to be a square. At this point, I'm going to switch over and use my graphing calculator to help me maximize the area, to figure out what the maximum, or what the x value should be to maximize the area. So I've gone ahead and already typed in my equation. If you need to do that, go ahead and pause the video and do that. And the toughest part about this problem might be actually setting up the window so we can see the parabola that we want to see. I'll give you a few shortcuts to doing that. So if you hit graph right now in the standard window, you're not going to see much of anything. The parabola goes up and I don't see anything. So let's adjust the window. In this case, x stands for the dimensions of the side of this rectangle. Well, the smallest x would be 0, although it wouldn't be a rectangle. And then the biggest x could be before I don't have a side anymore. Well, 400 minus 400 would be 0. So 400 is the absolute biggest that x could ever be in this problem. As far as your output then goes, the y, the output is area in this case. Well, my minimum area could be 0, and the maximum area I don't really know, but here's where we're going to kind of cheat a little bit. We already discussed that the maximum, this problem is kind of dumb because the maximum area, the best shape to use is a square. That always has the maximum area. So I know that if I have 800 yards, the sides of this should all be just 200 apiece to make it into a square. So I know that the best area is going to be 200 times 200. If that's, I mean, those are going to be, that's the best area I can do. So 200 times 200. And even though I don't know what that is off the top of my head, maybe I can just type in 200 times 200 and I'll pop up with an answer of 40,000. Now, if you didn't know that, you could just guess and check and pick numbers and see what works to see a parabola where you see the maximum. But look how perfect that is. It's just great. So let's go ahead then, and now that I can see the vertex of this parabola, let's find this maximum point. So we've done this part several times. So hit second trace. Option 4 is your maximum option. They're going to ask you to go to a little bit to the left, although it's popped up as the answer right there. We'll pretend we don't know that's the answer. A little bit to the left and press enter. A little bit to the right and press enter. And then guess, just wherever. And I'll see that, hey, like we knew all along, it's 200. Sometimes they give us a little bit off like that for whatever reason. But the maximum, or the x value that I should use to maximize area is 200 feet, or yards in this case, which means the dimensions of this rectangle, if I plugged in 200 for x, well, 200 right there. 400 minus 200 is 200. Look, just like we predicted, it's a square. 200 by 200 is going to be your best shape to use. And then if they ask us to find the actual maximum area, well, that's your output value, the y value. So 40,000 square yards would be the biggest area that we could make with 800 yards of fencing, and that's if we made a square out of the fence.